Welcome everyone to this special community talk. We are very happy to see you all here. This is an exceptional community talk because we will take more time to elaborate on the topic of infectious diseases. As it is exactly 5 years after the beginning of the COVID pandemic, we wanted to make use of this momentum to have in-depth discussion on this topic. We would like to welcome the speakers. We will start with Annelies Agten from the University of Hasselt in Belgium, who will give an introduction to ongoing projects and collaboration opportunities within VLIRUOS. 3 scientific presentations will be given. First one will be given by Issaac Singini from the South African Medical Research Council in South Africa, who will discuss the application to HIV and tuberculosis. The second presenter is Levi Mugenyi from the Makerere University in Uganda, who will give a presentation on age and time-dependent malaria course of infection. And the third scientific presentation will be given by Khangelani Zuma from the Human Science Research Council of South Africa, who will share lessons learned on the HIV surveys over the past 20 years in South Africa. And then lastly, Ziv Shkedy and Niels Hens from the University of Hasselt will give a summary and conclude this community talk. So as you see, we have a full and interesting agenda. So before we start, allow me to make 3 practical announcements. Firstly, throughout the presentation, you can raise your questions in the chat. We'll make sure to discuss them during the Q&A. And be aware that we have a Q&A session after each presentation, so you don't have to keep your question till the very end. Secondly, during the presentation, please mute yourself. However, during the Q&A, feel free to unmute yourself, put your camera on, and to direct your question or to address your question directly to the presenters. And then finally, be aware that this community talk is being recorded. We do this so that we can share the recording afterwards on our website and YouTube channel. So without further ado, let's dig in. We hope you enjoy this community talk.
Okay, good morning all. Thank you, Laura, for the introduction. I hope you can all see my screen, should be fine. So I'm Annelies Agten. I will give a short introduction. We thought it might be nice to kind of situate where we are coming from the Hasselt side. Most of you might know us. Maybe there's some people who don't know us. So yeah, that's where I'll start off. So we're from Hasselt University, which is a rather small university situated in the north east part of Belgium in Limburg. Small university, but with a strong civic mission. So it's really focused on creating strong collaborations and engagements really at a regional level within Limburg, but also with society at a global level, which is obviously where also this community talks is situated at. Being a small university does not mean we cannot have big impact, and I think the presentations that you will see today will also reflect that. Specifically, a lot of the collaborations or the projects that will be talked about now are all in statistics. So also we are situated at the Center of Statistics in Hasselt, founded almost 30 years ago now. 10 years after the creation of Senstat, or the birth of Senstat, we already learned that collaborating makes you only stronger. So the Inter-University Institute in Biostatistics, or iBiostat, was founded, which is a collaboration or an institute that covers under University of Hasselt and also KU Leuven. Biostatistics, so statistics really applied in the with applications in the biomedical field, which means that we really need people with multidisciplinary backgrounds, not only statistics and mathematics, but also background in biology, biomedical sciences, computer sciences, and so on. And that's what laid at the basis for what we now know as the Data Science Institute as a part of UHasselt. And the Data Science Institute is actually an umbrella institute that covers not only Senstat, but which is a joint union of different research groups within UHasselt that covers obviously the Center of Statistics, but also computational mathematics, rehabilitation sciences, computational sciences, etc. And the vision for this, or the ultimate goal of the Data Science Institute, is to really be a one-stop shop. Try saying that 3 times for data science. Because if we think about data science or statistical analysis, we often only think about these 2 steps, and I think the projects that will be presented later will also cover a lot of those steps. Data analysis, model building on data, and evaluating how fit the data, or the data, the models. But for data science and for real-world applications, you often need way more than that. You need software that can automate certain processes. We need data management, data wrangling, etc. And so by having this umbrella institute that covers the different aspects of data science, so not only statistics and mathematics, but for example, computational sciences, etc., we can really tackle all the problems and real-world applications that are data science related. Now, most of the collaborations are or stem from statistics-based backgrounds, so for the Center of Statistics. And within that umbrella, we also have different research themes. The 4 main research themes you see here are biostatistics, statistical bioinformatics, quantitative epidemiology, and mathematical statistics. And as you also can see also later on, it's not only multidisciplinary, but also very multicultural. So we have people from very different backgrounds and places of birth around the world. To go a little bit deeper into some of these topics, it will not be an extensive overview, but just to give you an idea of what we do at Senstat or at the Data Science Institute. If we think about biostatistics specifically, it's easy to make the connection with clinical trials or risk assessment. So clinical trial methodology refers to design and analysis of clinical trials. And at the Data Science Institute, a lot of our researchers have developed advanced methods to analyze this sort of data. Senstat researchers also participate in data monitoring boards and clinical trials, and we provide statistical support to external partners. Often these are pharmaceutical partners or government agencies. If we think about quantitative methods for risk assessment, for example, there's collaborations with the European Food Safety Agency in risk assessment, specifically related to food, but also drug safety, etc. Another field, and I think this is going to be the main focus of today as well, is quantitative epidemiology or infectious disease modeling. Our group has done a lot of work in infectious disease modeling, or developing mathematical models to map and predict the transmission of infectious diseases. And examples include influenza, measles, Ebola, HIV, etc. So it's to model the transmission not only between humans or between animals and humans, and at different levels, a global level and one we are all familiar with, and which is also the inspiration for the talks of today is obviously the COVID-19 pandemic, where specifically the Data Science Institute has proven to be very valuable, and where we've really been able to show our expertise. A lot of researchers were part of modeling the disease spread, specifically in Belgium, and we're also in a lot of advisory boards concerning the pandemic. And yeah, a lot of our collaborations in the South also reflect or are based on this research topic. Then we have the bioinformatics side, and if we think about bioinformatics, we think about different high-dimensional data, often also referred to as omics data. The genomics, if we go into DNA research, proteomics, proteins, metabolomics, transcriptomics, etc. And so the challenge here lies in integrating all these big data sets and finding common properties and creating software tools and methods that can deal with big data and highly structured data. And then lastly, I've talked about a lot of applied statistic or applied research groups, but obviously we cannot have applications in the real world without having a strong theoretical basis and background. So luckily, we also have a mathematical statistics or theoretical statistics research group that really look at fundamental statistics and that lay the basis for all the methods that we currently use, and new methods, obviously. Now, Data Science Institute is part of Hasselt University, so obviously research and education are two strong focus points. But at DSI, we also have a consultancy unit. And so the consultancy unit is really external partners. This can be companies, government agencies, other universities, other institutes that can use the consultancy service to tackle very specific projects or problems. When a consultancy project comes in, we just look at whoever has the right expertise to tackle the problem at hand. And because we have this nice umbrella of different disciplines within the Data Science Institute, we can really tackle any problem that goes from just a simple analysis to building software that can handle complicated data structures. And we believe at Sensat and at DSI that there needs to be a cross-fertilization between these three main objectives, so they don't stand alone. And specific examples include, for example, the cross-fertilization between consultancy and education. Within our Master of Statistics program, which I will also refer to later, a lot of the master thesis projects that students do whenever they are in the last year of their master come from companies or institutes outside of Hasselt. And so they really work on problems within that company, which is a benefit for the student because they get real life, real world experience at a company or at another institute. And it's a benefit for the company because they get a student with expertise in statistics that gets to work on a problem they have at hand. Another example of the cross-fertilization between consultancy and research, for example, like I said, whenever a consultancy project comes in, we really just look at the person that is most qualified or has the right background to tackle this problem. And often these are also PhD students. So we have PhD students that tackle also consultancy projects. These can be very short projects, but sometimes they also develop into a whole new research project. And this cross-fertilization between consultancy, education, and research also lies at the basis of the vision that DSI has when it comes to global collaboration. I've already shortly introduced that we have a Master of Statistics and Data Science at the University of Hasselt. And the Master of Statistics and Data Science at Hasselt is part of the ICP Connect study program, which means that we can award a certain amount of scholarships to students that are eligible from specific countries in the South. And what we see is that these ICP students often lie at the basis of, and also the goal, obviously, they lie at the basis of future collaborations with partners from the institute that these students come from. And what we see, or what is like a natural trajectory of collaborations with our partner institute, is that we first build up some statistical capacity. This can be in the form of workshops that are taught by U Hasselt, U Antwerp, Leuven professors at the partner institute in very specific topics like infectious disease modeling, citizen science, etc. They can be teach the teacher, so teach professors from the partner institute how to educate certain topics. And it's also useful for us to identify maybe good candidates for the ICP program. And then obviously the goal is to develop from there during workshops, during conferences that are organized, to also develop like a research based collaboration. It's not only teaching workshop, but really tackling research problems as a partnership between U Hasselt and institutes in the South. To have collaborations, or to be able to have these collaborations, project funding is very crucial, and for that we look mainly also at VLIRUOS, because they promote channels for collaborations with partners in the South. And I'll just give a very short overview of the types of funding, because I think that might be useful for potential new collaborators. But please do not hesitate to contact us if you have any questions about this, or VLIR. I think they will also be very happy to answer your questions. But specifically within VLIRUOS project, we have short initiatives. What's in a name? It's a short-term project designed to explore and build academic and scientific collaboration. They're very short-term projects, which means they often have clear boundaries. These are can be more research-based projects, and I will give some examples later on, but they can also be education-based initiatives. Then we have international training programs, or ITP projects. They're short to medium-term projects, and that's really to set up intensive, interactive, and practice-oriented training to enhance higher education management skills. So these are really more education-based. We have a lot of ITP projects currently also ongoing, and this is, for example, the workshops that are organized, some conferences that are organized at the local institute to build capacity, specifically in statistics, bioinformatics. And then we have team projects, also what's in the name. These are usually bigger projects, medium-term partnerships, and those are to really have academic and scientific partnerships between teams of academics. So these are often projects which incorporate multiple partners in the South, and this is really a combination of research and education-based collaboration. Next to VLIRUOS projects, there's also the bilateral scientific cooperation or BILA programs, and they really encourage cooperation between New Hasselt researchers and colleagues from partner countries as well. And BILA is you have the possibility for joint doctoral programs, but they also have mobility funds to really finance research stays here or locally. And then finally, the Global Minds program is also initiated by the Belgian government under the umbrella organization of VLIRUOS, and they offer funding for initiatives that also contribute to the goals of internationalization, and examples include pre-doctoral visits, but also mobility grants, again, for research stays or to travel for research purposes. Now, an overview of where we are currently active and collaborations we have currently ongoing. You can see that we're active in 3 parts, but the main focus lies on South and Central East Africa and Southeast Asia, and in a smaller capacity in Central and South America. Let's focus first on the African continent. These are current and past projects that we've had going. And as you can see, we have all types of collaborations, both short initiatives, an ITP project, and since this year, also a team project. I'm not going to go into detail into all of the projects, but I'll highlight a few. For example, we have a short initiative in the Democratic Republic of Congo, which is Solar Cookers for All. And the project aims to develop, test, and employ novel solar cooker devices that are manufactured locally in resource limited settings, and with a focus on acceptance by the community. And as a part of this project, actually, students at U Hasselt from bachelor or master, not only from statistics, but from different programs, get the chance to apply to be a part of this project in very different capacities. It can be from building testing stations, building prototypes, being part of the engineering side of it, being part of the business side of it. And so they really get the chance to work also on the project and go there to the DRC to be hands-on with the project, which is quite nice. To highlight another type of project is the ER Biostat ITP project. And this, as you can see, is already a collaboration between different countries, which is really nice. And the goal of this project is to develop an e-learning platform in biostatistics. And I'll give you a short example of what it looks like. So it's really an online platform, open source, and it includes courses in different topics in biostatistics, from basic courses to more advanced courses. And the goal here is really to provide course materials. So if you are a teacher, or if you want to learn yourself, but if you want to educate other people on a certain topic, then these are basically ready-made classes with also very specifically how to program in R. It includes scripts, it includes example data, and it includes slides. So it's really a ready-made course to be taught, which, if we think about it, is bigger than just this ITP program. It can be useful We also see it that people from all over the world have already used it, but also people at DSI themselves that have a less strong background in statistics can really use this platform. If we then look at Southeast Asia, we also have different projects ongoing. An ITP project that's in the Philippines that really focuses on environmental citizen science projects. So there have been workshops on how to do citizen science, how to analyze the data, what are the pitfalls, etc. And if I'm correct now, also a short initiative has been applied for that is like a continuation of the ITP project. And again, since this year, we also have a team project going on. I think Ziv and Neil will come back to this. There's a lot of workshops planned both in Africa and also in Southeast Asia on specific topics in biostatistics. And then lastly, I will not go into this in too much detail. We used to be quite active in Cuba, now less so, but we still have a team project going in Ecuador. But so Central and South America are a little bit less represented in our collaboration. And yeah, to wrap up, some activities that we have done in the past, or for example, the South workshop. These are really joint workshops. We have professors also from UHassel, but in collaboration with Antwerp or KU Leuven, and their workshops on very specific topics. They focus on knowledge exchange, not only from us to the institutions, of course, but it's really a dialogue between different institutions. And what we see is that at these workshops, we lay the foundation for future collaborations. In September, I believe, we had actually a similar setup as now, and this Alumni and Friends Network event was also the event that sparked the idea for this Community Talks XL event. But we had an event also with speakers from different collaborators, in which also over 100 people were present. We had a lot of dynamic discussions and interactions between different partners, which was very nice, and we plan to do this on a yearly basis. And then a last example is master thesis projects in the South. So Master of Statistics students or people in the Master of Statistics and Data Science at UHassel also get the chance to perform their master thesis with partners in the South. And some examples include Mel Solano and Paulo Badira, who have done it in the past. And I think this year we also have one student doing their master thesis with a partner in the South. And yeah, that's it for me. It's a short overview of who we are and what we do currently. If you have any questions, if you have any ideas for future collaborations, please feel very free to contact either one of us. Leila Kodalcic is the coordinator for the ICP program. She could unfortunately not be here, but you can always contact her or with any questions or information. And with that, I've talked long enough, and I give the floor to the next speaker, which is Issaac Singini. Thank you very much.
Thank you, Annelies. Let me share my screen.
Yes, thank you, Annelies, for the nice presentation. Maybe meanwhile, if there are some questions from the audience, feel free to raise them. Don't hesitate. So you can raise your hands in the chat so that we can see that you want to ask a question. But of course, if there are any, then we can move forward to the next presentation.
Can you see my screen?
Yes, we can.
Okay, fine. Thank you and good morning, everyone. You'll notice that the topic is not the same as the one that has changed because the topic that I was intended to present was not fully developed. So I asked for a switch and Ziv kindly accepted that I should change the topic. And so what I'm going to discuss today is about the two-stage joint model where we applied the variance shift outlier modeling and importance sampling. The motivation for this work was on the ongoing work that we're working on with Professor Gumezi, where we're developing diagnostics for the shared parameter joint model. That's where we got motivated to explore if we could work on a two-stage joint model because there was recent knowledge by MAF and Professor Rizopoulos about the uncertainty bit of the two-stage joint model. So that's my outline. I'll do some introduction, a bit of history, the methods that we used, and the applications that we did to a clinical trial data set and some key results, and then I'll make conclusions and there are a few references that I have included. So commonly in medical research, there are instances where we collect biomarkers which are observed maybe in patients or participants over time. And along the way, we also notice events of interest. So traditionally, the analysis was done separately. So you would create profiles, or you would create longitudinal profiles of a biomarker and see whether there was disease progression or not. And you also analyze the event times separately and report the results. But this has been, for the past 4 decades, was deemed to be suboptimal and like to jointly analyze the two processes. And that's how the joint modeling became a prominent area of research in the past 4 decades. But in this talk, I will limit myself to a two-staged approach, which because of new knowledge, probably it could be the one that people would opt, especially when you are faced with influential or outliers in the longitudinal marker. So initially, the two-stage joint modeling was short of a component where the uncertainty from the first stage was not propagated into the second stage. And to get around this, thanks to MAF and Rizopoulos, they have worked on the Bayesian framework, where the uncertainty is propagated into the second stage. And the goodness with the two-stage joint model is that it's that of its simplicity. At the same time, it doesn't have a computational burden in terms of estimation. And also, if you look at the longitudinal marker, oftentimes you'll be faced with outliers or influential observations or subjects. In the traditional case, the ideal situation was to maybe do a sensitivity analysis where you exclude outliers or influential observations from the modeling process. But then if you are faced with a small sample size, then the power of the study is not good enough to capture the or observe differences. And Prof Freedom Gumezi developed the variance shift outlier model, which instead of taking out outliers in the modeling process, you just downweight them so that they are consistent with the rest of the data points. So in this research, what we did, of course, we published this work in 2019, 2020. in Computations and Statistics journal. The idea was to develop the two-stage joint model whilst we incorporate the variance shift outlier model, which improves the robustness of the estimates. At the same time, we incorporated the importance sampling, which was new knowledge at that time, to mitigate the fact that the uncertainties from the first stage would not be carried through to the second stage when you are estimating the survival component of the model. And this, we applied this to a real data set, which was published in 2014, the IMPI trial, the famous IMPI trial by led by late Professor Bongani Mayosi. So as history, just as a history, when in the past, when the Cox model was being developed, event times were analyzed, of course, and then with their fixed effects, which could be baseline effects that would be introduced in the model, and then you'd ignore all the longitudinal markers that you collect afterwards, which again, it means that you are losing information from the baseline, from the longitudinal markers, which are collected over time. And then there was this development where the fine and gray model was developed, which would fit what is commonly known as the extended Cox, where you put in the model as a time varying covariate. But the assumptions of this model were that there is no measurement error, which is not practical, and that the biomarkers would remain constant at the time that you collect up to the next time that you collect. So between two visits, the assumption is that there would be constant, the biomarker would be constant, and this introduces the step function. The other assumption, the other stringent assumption in the extended Cox is that there is no link between the underlying longitudinal trajectory and the risk for an event, as demonstrated in the graph below, which was borrowed from Professor Rizopoulos. And this is not practical. And so there has been active research to say, oh, okay, why don't we try a two-staged approach, which would address the problems with the extended Cox. And the steps that are taken in the two-staged approach of a joint model is that you first of all fit the linear mixed effects model, and then you take subject-specific trajectories from the linear, or predictions from the linear mixed model, and then you use them as a time varying covariate in the Cox model. And therefore, this would smoothen and the trajectory. At the same time, it would link the longitudinal trajectory to the event times. But then this had its own limitation in that the uncertainties or the variability in the first stage would not be carried through to the next stage. So that was the main limitation at that time for using these models. So that's just by notation, fit the linear effects, linear mixed effects model, and then use these predicted as time varying covariate in the survival submodel. So we implemented this in a trial called the IMPI trial, which was assessing the two candidate interventions in a TB of the heart who were predominantly co-infected with HIV. And of course, despite treatment interventions in the recent times, there's still, the mortality is high amongst those that are TB and HIV co-infected. So the idea is to understand if we could have a joint assessment or a joint modeling between the survival outcomes and the longitudinal marker. And in this case, our longitudinal marker was CD4 cell count. So this trial, of course, was 2x2 factorial design, assessing two treatment effects, prednisolone and mycobacterium. And the primary endpoint for the main study was a composite outcome of death, cardiac tamponade, and constrictive pericarditis. But in this research that we published, we only focused on the constrictive pericarditis because it showed that prednisolone had a beneficial effect to the outcome, which is constriction. And the population the sample size that we used was about 500. So we assumed that the CD4 cell count could be modeled as a linearly, as you can see from the spaghetti plot. And the main study, as you can see, was that the intervention arm, which was the prednisolone, was protective from constriction. And having done that, we had run a case deletion diagnostic to identify outliers in the CD4 cell count. And we did this at two levels. One was at the subject level, which were individuals, and the other one was at observational level. Like at each visit point, were there any outlying or influential observations or subjects in the CD4 cell count, which we noted a few. And then we said, okay, let's do a sensitivity analysis. We ran the model with the outliers in the model, and the other one was without outliers in the model, and compare the estimates. And we noted that there was kind of the difference in terms of the hazard ratios between the full model and the reduced model. Of course, it was not statistically significant if you look at the confidence intervals, but there was a kind of reduced effect in the hazards ratio when we omit influential observations or subjects from the modeling process. And then this then calls for why can't we try to implement the variance shift outlier model, which downweights outlying objects and so that they are consistent with the rest of the data points in the model. And this ensures that we maintain the statistical power of the study in cases where the sample size is not large enough. So that's just the formulation of the variance shift outlier model, but I would like to draw your attention to D, which is a column vector, where it zeros in all places, but there's a 1 at the point where we have that subject or that observation. And this makes it handles the identifiability of the equation or of the model. So in simpler terms, to identify an influential or an outlying object is by the variance inflation. If, for example, the parameter omega is as a large value, it means that that observation is influential. But this is based on variance components. And then once we identify these outlying observations or subjects, the idea is to downweight them so that they are consistent with the rest of the model. And then we run the linear mixed effects model and integrate it in the survival submodel in the 2-stage. So of course, when we're running this variance shift outlier model, it's based on hypothesis testing, where we test the hypothesis that the variance inflation is not there, which means omega is 0. And the alternative is that there is inflation, and we say that the variance inflation, which is denoted by omega, is large. And this is done using like root ratio tests. And you understand, or you'd agree with me, and that this one is done multiple times, and therefore it introduces multiple testing in the process. So there are two challenges with the hypothesis testing of the variance shift. One is that under the null, we assume that it is 0, and therefore it violates irregularity conditions for asymptotic theory. And to mitigate this is we saw Pino and Bates and then Kumedze did some simulation studies to introduce mixture distributions. And the ones that were working favorably was the 0.6 chi-square distribution and the 0.32 that was giving optimal results for these mixture distributions. The other challenge is that you are faced with multiple testing, and therefore you have to account for that. And one way is to do bootstrapping or apply these traditional methods for accounting for multiple testing. One of them is of course, the benforanim, but in this case, in this study, we use the Benjamin-Hochberg procedure to correct for the false discovery rate in multiple testing. So that's just what we got. So we did, we ran quite a number of variance parameters, various components, and the variance inflation rates on each subject that we identified as outlying or influential, and those were the estimates that we had. And graphically, we identified these. So here, of course, you can't see, but here I just singled out the observation level variance components, variance or shift components that we had identified using the variance shift itself and the variance, the error rates and the likelihood ratio tests and the p-values that we obtained from the estimates. So what we noted here is that after running the first V variance shift outlier model, which was based on the subjects, and the second one was the variance shift outlier model based on the observations, and the third was the combining the observations and the subjects in one model. What we noted that is that the model that was done at the observation level was giving us a better fit in terms of the goodness of fit statistic. So, but the estimates were about the same. They were not different. It's just that the goodness of fit statistic using AIC and BIC was better in using the variance shift outlier model at the observation level. So in terms of importance sampling, which was a research area for Katia Maff and Prof Rizopoulos, the idea is to do a resampling technique for approximating distributions using the Bayesian framework. And this provides kind of a computational gain because it is not that computer intensive. So the process is basically fit the longitudinal model and then do importance sampling to account for uncertainty and propagate these uncertainties into the survival submodel in the second stage. So that's just a cartoon of how this is done. So you fit the longitudinal model and you do importance sampling and you propagate the uncertainties into the second stage of the survival modeling, which is where you are fitting the predictions or the predicted values as time varying covariates in the extended Cox. So that's how the process works. So in summary, what we noticed is that the variance shift outlier models kind of improves the model robustness if you are faced with outliers by keeping these outliers in the model as opposed to excluding them from the modeling process. And the important sampling is coming in because you can propagate the uncertainty from the first stage into the second stage. And this combined approach gives a better or enhances the predictive performance, particularly in the second stage, and therefore providing reliable estimates in the presence of complex data structures. So in terms of computing time, we noticed that the important sampling, as I said earlier, has less computer burden and the predictive accuracy is higher as compared to traditional Markov chain Monte Carlo techniques. So as for application into health research, of course, the idea is to improve prediction of disease progression and patient outcomes, as well as improve decision-making in terms of clinical judgment using robust statistical estimates. Again, it is feasible when you have large-scale epidemiological data or studies where you would want to deal with computational issues. So as limitation of future research, it would be nice to extend these models to dynamic treatment adaptations or personalized medicine, as in a latent class joint modeling, where the focus is in identifying distinct classes or categories where you can have a targeted approach to clinical outcomes, and therefore personalized medicine comes into play. And then we also need to validate these methods using like diverse real-world data sets. And also nowadays, the big data or machine learning techniques may also enhance prediction if we can explore a hybrid approach. So the take-home message is that the variance shift outlier model improves the robustness of the estimates from the two-stage joint model, and important sampling handles the uncertainty from the first stage of the linear mixed effects and propagates it into the second stage, where you're using it in the survival model without sacrificing the accuracy. And these can be applied to a number of medical research domains. Yeah, as an acknowledgement, we thank the participants that they gave us the data and the MIOSI group. And thanks to the South African Medical Research Council for facilitating this, and of course, to Prof Ziv and the entire US team for allowing us to be part of this community talk. Few references, thank you. And that's it for me.
Thank you very much for this interesting presentation. Maybe before going further with the next presentation, I would like to open the floor for some questions. There were already quite some questions in the chat, but mostly I think were addressed by Professor Agten or Professor Niels Hens. But there is now a latest question from Tumushime. Feel free to maybe direct your question, to ask the question directly to to Issaac Singini. Or I can maybe read the question. Oh, yes, thank you.
Yeah, thank you very much, Issaac. Just a quick one, maybe just read it verbatim as it is. Very pleased, of course, to learn of this new information, but I just wanted to inquire, in the event that I'm dealing with a data set that has lots of missing information, how do I then apply this variance shift outlier model to try and, benefit from its robustness, if that's applicable anyway? Over.
Yeah, so in the in the two-staged model, it may be difficult to just apply the variance shift outlier model to handle missingness. In that case, you have to rely on the missingness mechanisms that you know whether it was missing at random, and deal with that before you apply the variance shift outlier model. But there is a shared parameter joint model which handles missingness in a longitudinal marker. So in this case, you may have to fall back to run the shared parameter joint model which handles missing data. And or it also handles informative censoring when there is an event and then you have got missing data in the longitudinal marker.
Hope this answers your question. Perfect, thank you. Are there more questions or people who do research in a similar field who want to share their own experience? Otherwise, we can move forward to the next presentation. Of course, also there, we will have time for Q&A, and you can come back to this as well if you want to. Okay, great. So thank you again for the nice presentation, very interesting. And the fact that there are not that many questions, maybe it's because it's very clear. So thank you for that. I would like to now give the floor to Dr. Levi Mugenyi from Makerere University of Uganda. He did research on age and time-dependent malaria course of infection, and he will take us through his research. Thank you.
Okay, sorry, I was on mute. Thank you, organizers, for this webinar. I'm Levi Mugenyi, and I'm going to present part of my PhD project that happened between 2013 and 2018 from Hasselt University, and the sponsorship of VLIRUOS. So in this PhD project, we wanted to estimate transmission parameters for malaria. And one of the chapters or topic was focused on age and time-dependent malaria force of infection, where we wanted to account for unobserved heterogeneity. This was under the promotion or supervision of Neil and self-study and co-supervising by Stephen. So a simple outline, I will give you some introduction, then I will dig into how we estimated the age and time dependent malaria force of infection. And later, I will outline a few additional research we have done regarding malaria transmission. And I'll just talk a little bit of what I'm currently doing. So as an introduction, I started with the epidemiology of malaria. So malaria follows, it goes in a life cycle from the vector, which is the mosquito, to the human, who is the host. So in this diagram here, you see the white arrow is showing the transmission stages of the malaria parasite in the mosquito, and the red arrow is showing the transmission stages of the malaria parasite in a human. So what happens is that when you get bitten by a mosquito, when a mosquito is basically trying to feed on you to get blood, mainly which is the Anopheles one, the female one, with the purpose of feeding the eggs to grow, or to grow for the eggs. Now this mosquito, if it is infected, will transmit the parasite into your bloodstream, and this parasite first grows in the liver, where it first grows, and then it moves into your bloodstreams in the red blood cells. It takes several stages within the body, and then later it becomes infectious, and at this point it takes a stage what we call the gametocytes. So these gametocytes, which are infectious, when picked by the mosquito, then we infect that mosquito. So meaning, if the mosquito was not infected, human beings, we are responsible to infecting it. And if it is infected, then it can infect another human being. And at the time it infects the human being, the stage of this parasite in the mosquito is said to be a stage of sporozoites. And in Uganda, where the data that led to this project comes from, malaria is still a serious problem. In figure 2 here, I'm trying to show you by then what motivated this project, where we looked at the number of children that were dying from a database of the Mayuge Iganga. This was a surveillance site. And they collected data on different causes of death among children aged below 15 years. And in this data set, it was shown that children were dying, many of them were dying before they make 1 year. And when we looked at the responsible cause of death, we saw that malaria was contributing to more than 50%, at least 50% of the death documented of all those dying from other causes. So among children below 15 years, more than 50% of them were dying from malaria. And I tried also to look at the most recent work, again, by this same project, surveillance project, for data collected between 2018 and 2013 from 23 health facilities. From their publication, I'm happy I saw Dan Kajung here, who is actually leading this, this surveillance. So they documented the 5 topmost diseases, and they found again malaria was contributing to about 46% of all diagnoses made among this study population. So meaning malaria is still a serious problem. And as of now, we are trying to do vaccination of malaria. And the Ministry of Health has rolled out the campaign. They are still trying to do community sensitization to accept the vaccine. And we are planning to roll out the vaccine in April on 2nd in a way of protecting children in about 105 districts against malaria, where the malaria is more prevalent. So malaria transmission involves several parameters which are of key. So I told you we start with the mosquito which spreads malaria, and then we talk about sporozoites, which are the infected, which are the parasites that are found in an infected mosquito. So this sporozoite rate, which shows the proportion of mosquitoes that are infected or infectious. But also we have a parameter what we call human biting rate. So this shows how many humans are bitten by a mosquito, say per night or per day. And so given these two parameters, we derive another important parameter, which we call the entomological inoculation rate, which shows the number of infections or infectious bites per person per unit time. Now, depending on how efficient the infectious bites are, then you can get infected. So we have a transmission efficiency parameter beta or B, which acts between the entomological inoculation rate and the force of infection. So depending on how efficient the infection is, you will get infected, and that derives us to force of infection, which this project focused on. So we wanted to estimate this force of infection to see how then we can modify a few of these other parameters. So with this force of infection, then the humans, we want to know the proportion of humans that are now infected. And that gives us what we call the parasite rate. Now, with malaria, once you are infected, it may not become a disease. So we may also want to know of those infected, how many actually become diseased. And if at all those who have parasites and those who are infected, we then derive what we call clinical malaria incidence, which is actually measuring the symptomatic malaria as the new cases of malaria observed over time. So with those very many parameters, and as I mentioned, we focused on force of infection. So this was given, with this previous work of Ross MacDonald, very many years ago, almost a century, more than a century, 1908, he developed a mathematical model, which we call the priori model. And this model has been modified, and several other researchers have used the model to estimate different parameters for malaria transmission, particularly the force of infection. But also we know that we can use existing data to model the transmission parameters. So sorry for that interruption. So with these statistical models, which are posteriori models, they are more flexible. We apply them to the data, and they are quite widely used. And this project wanted to link the two modeling frameworks, the mathematical models and the statistical models, as was recommended by Ross in 1916. And this was an interest of this project, and it was a gap for malaria transmission modeling. So how did we then go ahead to estimate age and time-dependent malaria force of infection? So this project of estimating age and time-dependent malaria force of infection, we wanted actually to account for unobserved heterogeneity as we're estimating the force of infection. We mentioned here that malaria is quite heterogeneous in that people within the same household may have different rates of acquisition of malaria, yet they are exposed to the same number of bites, the same environment, same mosquitoes. And you find some children in the same household, some of them are often infected and others are not infected. So they are quite unobserved data or unobserved explanations to why there could be differences in transmission of malaria. And this helped, this was an objective of this project. We also wanted to estimate the easy to calculate bounds of malaria force of infection in a way of linking the mathematical and statistical modeling frameworks. And we hope that with this flexibility of the statistical models linked with the mathematical models, we are able to estimate parameters, say from the statistical model, substitute into mathematical models to define existing transmission parameters. But also in this expression, like the transmission efficiency, which is given as entomological initiation rate over the force of infection. If we can estimate force of infection in a most flexible way, we are going to somehow help refine the estimate for the transmission efficiency of malaria. So this modeling component of this project was based on the PRISM study, which was done in Uganda between 2011 and 2014. And this was done in 3 sites, which was Nagongera, Warukuba, and Chihihi. Chihihi is in the eastern part of Uganda, Nagongera somewhere in the east, and Warukuba and Nagongera in the east. And these were different transmission areas, with Nagongera having the highest transmission of about 300, with an entomological initiation rate estimate of 300, and Chihihi was following, and then the least area was Warukuba, which had the least number of malaria infections. So we tried to understand this data from this PRISM study, trying to look at the proportion that are getting infected between the sites and also by age. So we are seeing, first of all, differences in sites, but also the infection tends to vary with age. Then we also looked at the calendar time, and still we are seeing some variation or increasing number or proportion of people getting infected by time. So these 2 graphs motivated the modeling of age and time-dependent malaria force of infection. And with this, using this PRISM data, which was for children between 0.5 or half a year and 10 years, these children were tested for malaria during routine visits and unscheduled visits. And for this project, we used a very simple model, mathematical model, which is the susceptible, infected susceptible model, which assumes that people move from the susceptible component to the infected and then back to the susceptible component. And with this, we are able to relate force of infection with the point prevalence, as we are going to see in the next slide. But for the statistical model, we've used a generalized linear mixed model, basically to account for the clustering, because it was longitudinal data, longitudinal nature of the data, but also people were coming, different people were coming, or more than one child were coming from the same household. So we also had the household level clustering. So for this statistical model, we used a fractional polynomial, which is very flexible, and we allowed different powers of age to range between -3 and +3, and we found the power that best fit our data. And for this model, parasitemia, which is showing the proportion infected of humans, it was binary in nature, And in the covariates, we consider the age and the calendar time, but because we also saw the differences in the region was included in the model, but we also wanted to look at the previous infection status. We wanted to know if those who were previously asymptomatic, as they were previously infected, but never showed symptoms, and those who showed symptoms, or those who were negative at the previous visit, how are they likely to be infected on the next encounter or the next visit? But we also wanted to look at anti-malarial treatment, because it is claimed or believed that once people get these anti-malarial drugs, they get some potential protection from the infection. So we also wanted to look at those who were previously treated and those who were never treated, to see if the force of infection acquisition rate of the malaria infection could differ. And this is a very simple mathematical model that we considered, the SIS model, where we have the S compartment and the I compartment with the lambda t, which defines the rate at which people leave the S compartment to the I compartment, which is actually called the force of infection. But once people get infected, of course, they recover. Now, in this model, we are not consider demographics, or like people who are dying, or those who are getting born into this cohort. So those who get infected can recover at a recovery rate gamma, and then immediately we are assuming they get infected. So this gives us a system of ordinary differential equations here, whereby if you look at S, and S as the proportion that are susceptible at time t, and the IT as the proportion infected at time t. So the two proportions ideally add up to 1. Now, with this assumption, we were able to take S, which is S as 1 minus IT, and we substituted into this second differential equation, and we were able to make lambda t the subject, and that gave us an expression of this nature. And this is the force of infection that is linking the recovery rate, but also the proportion infected. Now, when you look at this expression, which we derived, and you consider an Erlang distribution, whereby you consider that people within the I compartment can move into several compartments within I, whereby the first compartment, I, say I1, is where people have just gotten infected. And then say IJ is where people are most likely to recover. You will find that immediately people get infected, the gamma, the recovery rate is 0, or can be assumed to be 0. And later, when they have overstayed this compartment, they can recover. And that means gamma can take a value. So when you put a 0 here, and this term disappears, this gives you the lower limit, or the lower estimate of the force of infection. And so these two expressions can give us both the lower and the upper limit. And so what we have to do now is to estimate I, the proportion infected. And this proportion infected can be estimated using, say, a statistical model. Here we applied a generalized linear mixed model to estimate the point prevalence, or the parasite rate, and that is IT, and which we substitute easily here to estimate the force of infection for the two bounds. And the GLM model, this is, those of us who are not familiar with this model, maybe you can focus on this, that we have an outcome, which is the parasitemia in our case, the binary one, indicating 1 if 1 is infected and 0 if not infected. So you relate this into a model. And here you have a vector of covariates, and then you have a vector for the random effects. Which component of this model now handles the unobserved heterogeneity, which in this case we considered the random effect due to the data from the same person over the time, the longitudinal data, and as well as the clustering in the household. And with this, we are able to estimate the pi, which is the proportion infected, and then later we estimated the variance covariance matrix, which shows how much the variability is within subjects and between households. And this gave us the results from the GLM model, but at this point, just know that we are fitting a statistical model. And we are seeing that the odds of being infected were quite high, 8-fold in Nagongera compared to Warukuba. And this is where we have the high transmission rate. And when we looked at the previous infection status, we noted that people who were previously asymptomatic were also more likely to be found infected. As well, when you look at, for example, the shift age, we see an effect. But here we also see an effect, though you have to interpret this one as the inverse of age, because the power negative one from the fractional polynomial was found to best fit the data. So with the variance component, you could derive this, the variance, which is D11, which shows the variance for within subjects. And this is the variance between households. But what we note is that Warukuba, which indicated to have low intensity, the variance between households is quite big. And for Chihihi, it is following, and Nagongera, where we have high intensity of malaria, the variance between households is small. So we could conclude here that the variance was actually increasing with the decreasing intensity of transmission. And all these variance components were significant, meaning quite heterogeneous as expected for malaria, that quite, if you don't account for this unobserved heterogeneity, you tend to lose or to wrongly estimate your parameters. This graph, we try to show how the transmit or the force of infection is, considering someone who is born in this year, and considering lower bounds, the lower and the upper bound. So the lower bound is the green, the upper bound is a full bar, and then the difference between upper and the lower bound is the yellow here in this graph. So what we note from this graph is that in Nagongera here, this is Nagongera, just know that the first column is Nagongera site, second column is Chihihi, and Warukuba is a third column. But the top row are those who were previously asymptomatic, and the second row are those who were previously asymptomatic. So what we noted is that in Nagongera and Chihihi, these two sites, the upper bound, which is the full bar of force of infection, was highest among children who are aged 5 to 10 years. And in Warukuba, which is the low intensity area, we are seeing that the force of infection was highest among young children who were aged less than 1 year. So, and again, we see that previously asymptomatic children, when you see this bar, this bottom row and upper row, you see that the previous asymptomatic children had the highest force of infection regardless of the site. When you are in Nagongera, you are seeing longer bars here, and there compared to the symptomatic ones. And we also noted that for the lower bound, which is the green, and the force of infection in Nagongera, look at the Nagongera here, you see that the force of infection decreases with increasing age. See, it is the green here, high, then it keeps on going, and it is true for both symptomatic and asymptomatic ones. And yet in Chihihi, we are seeing when you look at the green, the lower bound, you see that the force of infection is peaking among children aged 1 to 4 years. And in summary, just to mention that we used cohort data of children aged half year to 10 years, and we evaluated for the presence of malaria parasites, and we considered 3 sites. So we derived a link between the SIS model, which is the mathematical model, and the GLMM, and we used the GLM to estimate the prevalence, and then substituted the prevalence into the expression now to estimate the force of infection. What we found is that force of infection varied significantly with age and was estimated to be highest among the older children. And this was true both in high and medium transmission areas. And also force of infection was highest in children below 1 year in low transmission settings. So because we observed significant variances, so we can say that heterogeneity was significant, and it was greater between households than between household members. And we observed that this heterogeneity is increasing with decreasing risk of malaria transmission. This work was published in this paper, which contributed also to part of my PhD. And in conclusion, we are saying that malaria is still a leading cause of mortality among children dying in age group 29 days to 14 years in some parts of Uganda. And the prevalence of force of infection has been found to be highest among 5 to 10 years and in high transmission areas, and yet it gradually decreases with increasing age, both in the medium and low transmission intensity areas. And the prevalence and force of infection take peak at 1 year of age in low intensity area. The infection risk was highest and lowest among previously asymptomatic and symptomatic children respectively, regardless of the transmission intensity and heterogeneity in acquisition of malaria infection. It has indicated to be increasing with decreasing force of infection, and it was greater between households than it was between household members. So in our recommendations, we said that when estimating the malaria force of infection, it is important that we account for both observed data or observed heterogeneity and unobserved heterogeneity if we are to refine malaria spread models. And we also think that there is need to expand this work to a more realistic compartmental model, which is SIRTS, which is looking at susceptible, infected, and allowing recovery because of treatment and multiple infections. And then once treated, they can then go back to the recovery, to the susceptible compartment. And we also want estimation of R0 to guide the proportion to be vaccinated. Now, this is very critical at this moment when Uganda is rolling out the vaccination of malaria, and we need to know the proportion that required to be vaccinated. And in our project, we never estimated R0, and this would be a very great addition to this work. But also, we needed to look at indoor residue spraying, which is very key in killing mosquitoes that spread the infection. And this is some work I did in my postdoc, as I'm going to show briefly here. And that in our modeling, we focused on the transmission in a human, yet we know this is a two-way. It's a human and the mosquito. We infect mosquitoes, and in return, they infect us. So the modeling approach that accounts for both the mosquito and the human probably could be more relevant and useful. So what are the other things we have done in regarding to malaria modeling? We have looked at, I mentioned to you that we have children who come to the clinic when they are not scheduled, unscheduled visits. And with such visits, we are seeing that they come because they are infected. So they are coming to the clinic for any assessment is because of the outcome, which is the infection. So here we are talking about outcome-dependent sampling. So this, in my project, I proposed methods to address the outcome-dependent sampling, but I'm happy this work was extended by Martin under the supervision of Stephen and Niels Hens. Then we're able to get this paper, of which I was also able to contribute. The other part, which was actually my postdoc, I mentioned in my recommendations that IRS is critical, and we need to see how we can reduce the mosquitoes. So when I came back from my PhD, there was a need to know, there were campaigns to spray IRS, but then it was not clear how often IRS should be applied. So I was tasked to propose optimal time that is required between rounds of IRS before another round can be given. We did some good work here, and we looked at different types of IRS, the bendiocarb and perimethos methyl, and we found that for this bendiocarb, one would require about 17 weeks. So every 17 weeks, you would be required to put up another round. But we know IRS is very expensive, and of course has side effects. And there was still a compromise between doing it as recommended or waiting. And we are seeing that when you take long before giving another round, the malaria comes back and in large numbers. So this is critical. And for perimethos, it was found to remain impactful for about 40 weeks, meaning it could remain, it's better than bendiocarb in protecting against malaria when it comes to spraying, but of course the cost is also involved. I've done some other work on malaria, like in this one, we try to look at the impact of to improve malaria care in public health. We look at the differential prevalence of transporter polymorphism, and then Plasmodium species infecting children. And these three research work have been published. So what am I doing currently? So after my PhD, I joined TASO, which again, I worked with for a few years, about 3 years. Then I moved to Medical Research Council, which is MRS UVRI and London School of Hygiene and Tropical Medicine, a Uganda-based research unit, which is in Entebbe, where I'm a senior scientist, a senior statistician. And with this, I was able to apply for a research fellow position with the London School of Hygiene and Tropical Medicine, where I'm now currently a research fellow. And we have recently established a partnership which is trying to strengthen capacity of statisticians in sub-Saharan Africa. And this partnership is called the International Statistics and Epidemiology Partnership. And we have had several meetings already, and we have done several trainings in sub-Saharan universities where we try to strengthen statistics. And in other work I do, I help a lot with the Makerere University with exam examination of the students. And I think I've already examined over 20 students there. I contribute largely on the DSMBs and the research ethics committees, both at the local institutions, but also on the national level, where we look at all the research that are being conducted in Uganda. And my contribution on these research ethics committees is basically the methodology and the statistics. I review many papers. A small bit about ICEP is that this was having 3 objectives. We want to get a supportive and sustainable network of early to mid-career medical statisticians, and we also want to increase the knowledge of medical statistics for global research and raise awareness of the need for increased capacity. So we held our first meeting, and I happened to be part of this big team, which the first meeting happened in Nairobi last year in February. And a few references there. I want to acknowledge those very many people, particularly Professor Neil for that PhD support, and Sarah and Stephen. But particularly, I want to thank the VLIR that supported my project. And of course, the PRISM study that provided the data, as well as this demographic surveillance, which is actually providing data on mortality. The first graph I showed you, and it was part of my project chapter, and of course, my family. Thank you so much. I will take questions, if any.
Thank you so much for your presentation. Thank you. And indeed, are there questions from the audience? I saw some in the chat. Let me try to find them. So if you put your questions in the chat, you're also very, you're invited to ask your questions directly to Dr. Levi Mugenyi, sorry. Let's see. There was a question from Mr. Adam Aragao. The question is, in the variance, sorry, I believe this was a question for the previous presentation for Issaac. So Issaac, if you're still there, you can maybe also answer. So in the variance shift model within the joint model, you considered the association with the FVSOMI parameter. What about the association parameter of the random effects with the survival submodels?
So I don't know whether I'm supposed to be the first to answer.
Sure, you can start, and then the other speakers, of course, are very free to add to that afterwards.
Yeah, so the two-stage joint model doesn't focus on the association structure between the longitudinal marker and the survival or risk for an event. It just takes into account that you can use predictions like subject-specific predictions as time-varying covariates in the survival sub-model. The model that takes the association structure or the association parameter for the longitudinal submodel and the survival or risk for an event is the shared parameter joint model, which handles the contingent, of course, contingent on random effects. You can quantify the association between the longitudinal marker and the risk for an event.
Thank you for that. Dr. Mugenyi, would you like to add to that? Yeah.
I did hear my question, though. I don't know which question was raised to me.
So there is a question, another question related to malaria. If in scope, the question is what or which preventive measurements have been taken so far to minimize the risk of contracting malaria?
Yeah, okay, sure. I'm seeing this in the chat.
Yeah.
So ideally, Uganda, like in Uganda in particular, we have done mass drug administration where we give prophylaxis for malaria among children mainly below 15 years. And these have been done in schools where children are given these drugs to prevent them from acquiring the malaria infection. And the other measure that has been widely done has been the indoor residue spraying, where I showed you that there was a need to know how often this should be done, and it was quite challenging. And the other measures that have been done, has been the distribution of bed nets. Like recently, as a Rotarian, we were able to distribute a number of bed nets in one district around Wakiso district, in one community where malaria was emerging. And yeah, so there are more initiatives to do this, but now after all these efforts, and we are still seeing malaria, the government of Uganda, with the support of WHO, they have now decided to take on vaccination of these children. And they are starting with 105 districts where we are seeing high to moderate transmission of malaria. So we hope that after this, then we shall be able to see a reduction. But remember, we are vaccinating, but we are not controlling other things, or like killing mosquitoes, which can maybe move from one district to another district. But as I also mentioned, it's quite difficult to vaccinate everybody, as this can be quite expensive, because they are going to vaccinate children. But remember, we, the old people, or the adults and older children, we are the reservoirs for the malaria infection. So unless if everybody is vaccinated, we are not likely to achieve a lot. But we really need to know how much of this proportion that should be vaccinated to have low malaria. And this is where I said R naught, like in my modeling approach, probably if someone else can take it up, can help us really know how much of this population that should be vaccinated. Thank you.
Thank you very much. There was another question also in the chat, but I think it's also referring to the presentation of Professor Issaac. So allow me to raise this as well. The question is, did you also do an analysis comparison between the two-stage joint model with the extended Cox model for time varying? And if so, did you find significant findings?
Hello, and thank you for that question. Yes, we did fit quite a number of models, and one of them was, of course, comparing the extended Cox and the two-staged model. The results were comparable, but the goodness of fit statistics were better for the two-staged joint model. But the results were comparable. It's just that the goodness of fit statistics like AIC and BIC were better for two-staged joint model.
Okay, great. Thank you for that. I propose we move forward to the last scientific research. But of course, if you still have questions for one of the previous speakers, you're still free to raise them afterwards, because after this presentation, of course, there will be a new Q&A opportunity. So before, so just maybe to have the agenda again in mind. So first, now there will be a last scientific presentation, and then at the end, a summary and a glimpse of the future activities and plans will be given. So I would like now to give the floor to Professor Khangelani Zuma. He's from the Human Science Research Council in South Africa, and he will share with us now lessons learned from the HIV surveys over the past 20 years in South Africa. So thank you, Professor Zuma.
Thank you very much, Laura, and also thank you very much for inviting us. As indicated, I'll be taking you through the HIV surveys in the last 20 years in South Africa, and we'll talk about the implications, the impact, as well as the lessons learned. Now, this is a study that we have organized, or we've been organizing in South Africa for a number of years. As you know, that South Africa is one country that is facing a devastating impact of HIV and AIDS, being a country that holds this unfortunate record of being of leading or having the largest number of people living with HIV. Now, this is a study that we first implemented in 2002, which was pioneered by our former president, Dr. Mandela, with an intention of getting to understand the impact and the levels of HIV in the country, which was funded by also the Nelson Mandela Foundation. And he was really hands-on as we were working together on this study. As you can see, some of a picture that we took when we were presenting the study to the former president. The study has been expanding in scope, collecting information in different components, different areas, depending on what we needed to know about HIV and AIDS. As indicated, the study was first implemented in 2002, then 2005, 2008, 2018, 2017, and now I'll briefly take you through some results of the 2022 survey. So this study actually provides major source of information for measuring the progress of the implementation of the South African National Strategic Plan for TB, HIV, and STIs. So these are some of the reports that we have actually published that are related to the study. So you can see a number of reports. And at the end, I will show you a website where you can download these reports, and the data actually that I'll be talking about is curated and is available for free on our website. And we always encourage people to download and make use of this data as part of our dissemination strategy. So this data has been disseminated to a number of stakeholders, and this information actually, as indicated, provides the level of where we are with HIV epidemic in the country. As you know, in a country which has got millions of people living with HIV, whatever happens in terms of HIV epidemic in South Africa dictates how the world is going to respond to that. So this was actually one of the forums where we're presenting the results at one of the International AIDS Conference with our Minister of Health, as well as the Director of the UNAIDS, Mr. Michel Sedibe, where the results were received about HIV and AIDS in South Africa. And these results have actually informed how we deal with HIV and AIDS epidemic as a country and as a global community, the improvements that have been made in terms of dealing with HIV epidemic. A big part of it has been driven by what we have been implementing in the country. And again, we provide reports, the statistics on HIV and AIDS in South Africa. We work together with UNAIDS, where we provide this information. We collaborate with UNAIDS on HIV prevention and research, and also policy development. We advise, as the team, we advise on what needs to be done differently to deal with HIV epidemic. We provide the statistics from this survey to the UNAIDS about where we are with HIV as a country. So it's information that is widely disseminated, widely used in dealing with HIV and AIDS epidemic. And in fact, a number of improvements, even in the policy interventions in the country, are guided by this study, and also the success and failures of different interventions is actually determined based on the results of this survey. Now, again, the team that is actually implementing in this study, this is one study in the country where actually the research that is being done is led by researchers from the South. So researchers from the North who come to South Africa, like our PEFA partners, they collaborate with us, but the research is actually led by researchers from the South. And also as researchers from the South, as leaders of this study, we collaborate with other researchers from other countries such as Botswana, Lesotho, Mozambique, and Swaziland, where we also provide technical advice when they are implementing their own study. And this study also offers capacity development in the sense that a number of researchers who joined the study around 2000 and 2005, who were junior researchers, they are actually now leaders in the study, part of the project directors and part of the principal investigators, and a number of them have actually also obtained PhDs using this data. So it provides also capacity development in the country and also abroad. There are also students from University of Hasselt who've actually visited us for a short time to work on this data and also acquired their thesis using this information. Now, this study contributes, as I said, to the way in which HIV surveillance is done in South Africa, in the sense that modeling of HIV data, before we call it, this is the SEPSAM study, South African Behavioral Social Surveillance and Media Study. Before this SEPSAM was done, we were using antenatal care surveillance data, which is the statistics from pregnant women. Now, with the invention of the study, model estimates of HIV prevalence at national level were now more representative of all ages, because with the antenatal care surveillance survey, it's only pregnant women who are part of the study. But with this, everyone is eligible and is included to participate in the study. And with this study, then in fact, the prevalence of HIV, because if you're using antenatal care surveillance data, you have to extrapolate to the general population using some assumptions. Once these data were available, the estimates of HIV prevalence were revised. So the SEPSAM, or the approach which you call a second generation surveillance survey that we use, of combining the questionnaire on one side as well as the specimen, the biomarker on the other side, so that we can analyze the two, called second generation surveillance survey, has been accepted as being more accurate, and even the global prevalence was lowered due to these data. Now, with this information that we collect with SEPSAM data, it has been used as an advocacy tool, and a number of other studies actually have emanated from these data. So we conduct a national survey, we identified some components which we need to investigate further, and other studies are conducted, such as we organized and implemented a study among educators, among health workers, and also we organize another big study where we're looking at what you call the Know Your Epidemic and Know Your Response, where we're looking at the review of what is it that has been done around HIV, what is it that we know, and what interventions are working. So that was just a synthesis of what has been done in the area of HIV. We also organized some studies among adolescents that are living with HIV in the country, doing detailed analysis over a number of years using this information. So there are many other studies that have come out of this data because of the findings, then giving us an indication that there are areas that we need to look further and fill in those gaps. Now, how is this study organized? This study aims to provide the estimate of HIV prevalence at national level, provincial, as well as district level. We collect data sufficient to be able to provide results at district, in a number of districts in the country. We also collect information to be able to estimate the numbers of people who are on ART, the numbers of people who are virally suppressed, and also to estimate HIV incidence. Now, as indicated, the study is representative stratified by all 9 provinces, as well as the districts in the country. We go to about 33 districts out of 52 districts where we collect sufficient information. Everyone in the country is included to participate in the study, and the data collection takes about a year to collect. We administer a questionnaire, a household questionnaire, where we collect information about the household situation, as well as a questionnaire that is administered through a parent or guardian for a child that is 0 to 11 years, a questionnaire that is administered among people at 12 to 14 and 15 years and above, where we collect detailed information about knowledge of HIV as well as sexual behavior. Just some specimen that we collect. Once we get to a household, we invite people to participate in the study. And then once people agree to participate in the study, we then collect, after we've administered a questionnaire, we then collect blood using what we call a Guthrie card. As you can see here, a Guthrie card, where we put dry blood spot. We test people if they're for their HIV status, and those that are HIV positive are also included. Sorry, once people test HIV positive, we then take their blood to another test where we test if they are recently infected with HIV. So we use that test, which tells us whether people have been recently infected or it's a long-term infection, so that we can estimate incidence. And then once we take another dry blood spot to another lab for testing whether people are actually on ARVs. And then another dry blood spot is taken to test or to measure the levels of viral load. So these are all the tests that are done in this survey. Now, just to give an indication of our, the dynamics of HIV, that is, we've got in the population new infections that are coming in, which are adding into the population of people living with HIV, which gives us the prevalence. Among those people, there are those that are on ARVs and those that are not on ARVs. And then those that are not on ARVs have a higher chance of dying. Mortality is much higher among them. And that's why we need to encourage people to be on ARVs. And obviously, those that are not on ARVs have got higher levels of viral load. And if they are having unprotected sexual intercourse, then they increase the risk of HIV transmission to other people. So that is what we need. Just to, in interpreting these results, we need to interpret these results in that context. When we organized the latest survey, the 2022 survey, we actually went to a total of 27,000 households that were found to have been valid, and they agreed to participate. Of the valid household, we found a total of 76,000 plus individuals in the household who agreed to participate in this study. And obviously, females were more likely to participate than males. And of the 30,000 women, of the 76,000 people that agreed to be interviewed, 63% of them provided blood specimens. So this is a very large database of people that participated in this study. What did we find to be the estimate of HIV prevalence in the country? We found that 12.7% of people were infected with HIV, and this translated to 7.8 million people living with HIV in South Africa. And this estimate was slightly lower than what we found in 2017, lower by about 107,000 people. And we want to believe that these people, the 107,000 people who died, these are people who died of natural death, but also there's a possibility that a number of these people might have died at a higher rate due to COVID-19 than those that were not living with HIV. So that is what we are trying to look at, if we could explain this loss of people, because now that people are on ARVs, people live longer. But with COVID-19, there's strong suspicion that mortality was higher among those that were living with HIV than those who were not living with HIV. Now, looking at the overall HIV prevalence by age, we see that comparing the two survey years, 2017 and 2022, we actually have HIV prevalence showing a shift in the epidemic curve, shifting towards the right-hand side, indicating that actually people are living longer with HIV, but we still have a problem among young people. Younger people in the ages of 0 to 14 are actually, we are not making a dent in terms of HIV epidemic. We find that 0 to 14-year-old from 2007, HIV prevalence has not changed in that age group. So 2.8 in 2017, down to 2.4 in 2022, which actually shows that we're still struggling to reduce HIV epidemic among these young people. So the mother-to-child transmission of HIV is still a problem in the country, because we can see that even though HIV epidemic people are living longer, with a shift towards the right-hand side, and also HIV prevalence dropping among the ages from 15, for example, to 24, which means they are prevented infections. But among the 0 to 14-year-olds, we still have a problem in that age group, which indicates that our interventions are not really working, especially to prevent mother-to-child transmission of HIV. And that is a concern. Now, what did we find when we look at HIV prevalence by different age group? We see that overall, we had 7.8 million people living with HIV. But HIV prevalence, or the numbers of people living with HIV, were much higher among older people than younger people. And that is an indication that people actually are living longer now with HIV. Let me go next. Yes. Yes. Now, overall, looking at antiretroviral treatment by age group, we see that of 7.8 million people living with HIV, we found that 5.7 million of them were actually on treatment. So 5.7 million people were on treatment, which is a slight improvement compared to what we saw in 2017, whereby 4.5 million people of them were on treatment. So people now are more likely to take treatment than they were before. And obviously before, the policy was that people would take treatment when their CD4 count was less than 500. But now we're using what you call a test and treat, so more people are taking treatment. But the concern is actually among, let me just point here, among people who are 15 to 24 years, whereby those people are less likely to be on treatment. And that is the concern. If you look in other age groups, more people are on treatment, likely to be on treatment, but the youth is the one that is less likely to be on treatment. Now, what did we find when we estimate HIV incidence using the recence of HIV infection the HIV incidence has decreased over the years. It's going down in the right direction, but we are still having a problem among those that are 15 to 24 years of age, where the incidence of HIV is still high in that age group. But it's dropping in the right direction, but it's still high, which means they are still young people that are getting infected with HIV. We estimated that overall, 232,000 people were infected with HIV in year 2022. So these are infections that could have been prevented, but infections still continue in those groups. Now, when it comes to the targets, now the 95, 95, 95 target, we see that there's been improvement in the target, that is the UNAIDS target, whereby overall 89% of people living with HIV know that they are living with HIV. And of those that know that they are living with HIV, 90% of them are on ARVs. And of those that are on ARVs, 94% of them are virally suppressed, which is a good thing. But we are still far below the target of 95, 95, 95. So there's still a lot of work that needs to be done to improve that. What are the key drivers, in brief, of HIV epidemic in the country? What drives the epidemic of HIV? Well, sexual debut, which is the age at which people start having sexual intercourse. By the age of 15 years, we found that males in 2022 were slightly more likely to report having sexual intercourse much earlier than females, which is at 15.7, even though there is a drop in 2022 compared to 2019, but males are still more likely to start having sexual intercourse much earlier than females. Again, the problem of age-disparate sexual relations among adolescents who are 15 to 19 years, you find that one of the biggest contributing factors is young boys who are actually having sexual intercourse. Sorry, young females who are having sexual intercourse with partners that are much older than themselves. So that is the problem that we face in the society right now, whereby with the age disparate sexual partnership, we find that people engage in sexual contact with older people, especially young girls engaging in sexual contact with older people compared to the other age group. Now, adults aged 15 years who had 2 or more sexual partners in the last 12 months, again, we find that males tend to have more partners compared to females, and that contributes to an increasing risk of HIV infection. And that is one of the contributing factors in the HIV epidemic. Condom use was one of the biggest problems that we face in the country, that fewer and fewer people are using condoms. As you can see, the numbers are declining. And the big concern is that this may be due to complacency, whereby because now there are ARVs, then people are actually saying, well, even if I get infected, I can take medication, which is a very risky thing to do. Circumcision is one of the interventions that have been shown to reduce the risk of HIV transmission. And we are encouraging people to be circumcised. And again, we can see there's slight improvement in terms of a circumcision, as it is one of the prevention tools. So in brief, actions that we think should be taken in the country is that there should be a long-term strategy to care for individuals in aging with HIV epidemic. So people now living longer, we need to prepare for other epidemics, or how to take care of people that are living longer with HIV. We need to continue intensive program focusing on reducing new infections among adolescent girls and young women. Heightened focus on campaigns such as U equals U, which is undetectable equal to untransmittable. We need to encourage people to be on ARVs so that their viral load is undetectable, and then the virus could be untransmittable to prevent new infections. Just by way of concluding, we see that HIV is stabilizing in the country. There is a reduction in the HIV incidence and an improvement in HIV treatment, but we still have a long way to go in actually reducing or meeting the 95-95 target. In conclusion, also, this study is one of the series that has emerged as one of the HSRC's leading scientific contribution to understanding HIV epidemic and response. It continues to provide data, essential data for monitoring HIV epidemic, monitoring the impact of HIV programs, to monitor, to inform strategies for epidemic control in the National Strategic Plan, as we see the wide use of this information. Just in conclusion, colleagues, this is a website where you can download this data and all other data sets that are available at HSRC. The data that we collect is available for free. If you have challenges, you are more than welcome to contact me. Then I can link you up with the people who are dealing with this information. This is the consortium of partners that actually conducts and implement this survey. And the funding that we get from PEPFAR, and again, we all know the current challenges that we are facing with PEPFAR. We don't know for how long we're going to be able to continue implementing this very important study. Just to list a few colleagues, a number of them are known to you colleagues who are collaborators or who contributed in this survey, with colleagues also from Medical Research Council, CDC, UCT, and also NICD, National Institute for Communicable Diseases. On that note, colleagues, thank you very much for your attention.
Thank you very much for the presentation, Professor Zuma. Very, very interesting as well, of course. Again, I would like to open the floor for this last scientific presentation, I would say. I'll maybe give the floor first to the ones wanting to ask their questions live. Please, Levi Mugenyi, go ahead.
Yes, thank you so much, Professor Zuma, for that wonderful presentation on HIV. I think I have two questions. One is about the long-acting injectables. I don't know if you have any comment or if this has been done in South Africa and what you have to comment about it. There is a graph which showed the trend in the infection of HIV, comparing age groups. And I noted when I look at the trend of 2017 and 2022, in 2022 for the age group 45, I think 55, there was a shift as having more of the people. So I was wondering if this shift is because of people aging with HIV, or there's a shift in transmission of HIV as like being higher among the older people, and hence older people being more active in transmitting the infection than the young people. Thank you.
Okay. The challenge that we still face in the country is that the shift is because of two reasons. People that are living longer, so we have a shift towards the right-hand side. But we still have a vertical shift in prevalence, which is because of people who are still getting infected with HIV at an older age. One of the biggest unfortunate phenomenon in the epidemic in the country is that you've got, for example, young females having sexual intercourse with older males in the age of 15 to 24 having sexual intercourse with older males who are already living with HIV. And now, at a later stage, you find that these young males are HIV negative for a long time. At a later stage, when they want to start families, then they have engagements with people in their same age group or slightly younger than them to get married to. And then most of the time, we find that those females would have been infected earlier than males. Then those males start getting infected at that age. So that is why you see a shift, a vertical shift in HIV epidemic, as well as a shift towards the right-hand side with people living longer. So that is the contributing factor to that. Now, about the long-acting drug, at this stage, what we only test is whether a person has been exposed or is taking any of the antiretroviral drugs that we use in the country. If the test comes out positive, then we record that, and we've got a set of drugs that are used in the country to deal with HIV and AIDS epidemic. Thank you.
Thank you for the question and also for the answer. Very interesting additional information. Professor Ziv Shkedy, can I give the floor to you to ask your question?
Thank you. So my question was related to the budget cut in US aid. And how do you think it will affect the possibility to do this survey in the future and to collect data?
Yeah, thank you very much for that question, Prof Shkedy. We are concerned, and we are very, very concerned. For previously, we did receive a stop work order where to pause everything. And at the moment, we're at the mercy of the judiciary in the US at this stage. And anything that would happen to the negative, that is cutting funding, it will mean that literally we'll have to stop collecting this valuable information unless if other sources of funding do come through. But at this stage, we are actually in a very serious challenge that if we don't get funding from anywhere or guarantees of funding from anywhere else, we may be in a situation whereby we have to forget about collecting this valuable information, and the epidemic of HIV, which is still there in the country, will go into the doldrums where we really, it's going to be a big mess, if I may put it that way.
Yeah, thank you for your answer. Although the outcome, of course, is not positive. It's a bit new to see how politics to see how directly politics influences science. I have two more questions I will raise before we go to the last presentation. Allow me to ask them together, maybe. So the first one is, there seemed to be a big class interval, like the age gap. For example, one interval was from 15 to 49. And the question is, do you think this hides a lot of information about HIV infection? It's a bit related maybe to the previous question. So the fact that the age intervals are big, does that hide a lot of information? That's the first question. The second one, can you say something about South Africa's situation compared to the neighboring countries? Do you see some gaps or overlaps, some differences in research output and results?
Okay, sure, thank you. Well, the one thing is the age gaps. Obviously, it's what we analyze, especially, for example, when we talk about youth, it's people who are 15 to 24, young ones, it's 0 to 14 years. So we analyze those wide age brackets. Obviously, there could be a lot of hidden information in there, but we are also guided by available information, especially among 0 to 14-year-olds, the sample size. There are fewer kids who participate in the study, so we're limited there. But the good thing is that in the data that we disseminate, we've got single-year age groups. Whoever is interested can download the data and analyze the age brackets in a way that they see fit. That information is there. Comparing the situation to the neighboring countries, HIV epidemic, as we know, it is worse in the sub-Saharan Africa. About close to 68% of the numbers of people living with HIV are found in the sub-Saharan Africa, few countries. So the situation is not unique to South Africa. But of course, South Africa has the largest number of people living with HIV, but other countries in the neighborhood are similarly affected by HIV and AIDS epidemic. And we are all working together in dealing with HIV epidemic. As you know that we provide technical support to one another so that we can deal positively with the HIV epidemic.
Yeah, thank you very much for the presentation and for the answers provided. Then lastly, I would like to give the floor to Professor Ziv Shkedy and Niels Hens, who will share a summary and also share some future research activities and plans. Please, the floor is yours.
Okay, maybe I will start with a very short summary of some projects, some meetings that we would like to organize in the near future. Can you see my slides?
Yeah.
Sorry,
yes, you can, but not in presentation mode. Yes, now we can. Perfect.
Yeah, so I just want to mention three meetings that we will organize in the near future. The first one is in Uganda. So if you are in Uganda or will be in Uganda in the 12th of May, in the week of the 12th of May, we would like to invite you for a meeting that we'll organize together with IBS Uganda. It's a meeting with a 2-day conference and 2-day workshop. And we'll be very happy to see you there if you are from Uganda or if you are willing to travel to Uganda. And if you are interested, please contact Kaylee. She was online in this meeting also. And we will send around some details about this meeting. So that's the first meeting. The second meeting is in South Africa, in Pretoria. That will take place by the end of June and the first week of July. It's also a meeting with a workshop and a conference. And if you are from South Africa, we will be very happy to see you there. And the last meeting, it's a Suzanne conference that's organized by the IBS, the sub-Saharan region of the IBS. This year it will take in Addis Ababa, in Ethiopia. It will be in September 25. And we will try to organize a meeting there in one of the evenings of this conference to have a meeting with all our alumni and collaborators. So if you plan to go to Suzanne, please let us know, because we really want to have one evening or one afternoon that we all meet there and discuss a few things related to collaborations. That's all. I would like to thank you very much, and now I'll give the floor to Neil.
All right, thanks a lot, Ziv. And well, first of all, I'd like to thank all the speakers. We've heard Issaac talking about the joint modeling approach. We've heard Levi talk about his PhD work, but also the work he's currently doing. And Khangelani, the very important work on HIV/AIDS as well. So I think from these presentations, it's very clear that biostatistics and infectious disease epidemiology are partners in crime in terms of making the best out of those data, informing policymakers, public health specialists, and so on. And I think that has been clearly shown in the 3 presentations. I'd like to emphasize that from Hasselt University, we're also actively participating and have participated in the COVID work, as Ziv has collaborated with several people in the South related to COVID-19. We're currently also working together with people on Mpox, on other infectious diseases, all under the umbrella of pandemic preparedness. How can we do better next time, but also looking at the current threats, which are maybe not pandemic as such. And I think it's really important that this capacity, that is something that we need to invest in, even more so. So what Ziv just presented in terms of the workshops that will come is trying to make this sustainable towards the future as well, and certainly related to the fact that we want to engage our alumni and friends, because it's not only alumni anymore, it's also friends, people that we got to know through our alumni, through our workshops and so on, that we want to engage with, to foster collaborations, to actually give people also the means to do this really necessary research on these challenges, like the Mpox outbreak currently in DRC, but also affecting other countries, so that you can work with the first data, the first outbreak data, to get insights and to inform policymakers in your country. So I think that's really important, and we'd like to support people in doing so. So feel free to reach out to us, to Annelies, to Leila, but also to Ziv and myself. Feel free to reach out to us, and we will look into opportunities to collaborate, to exchange information, and so on. And this is something that you will see appearing more and more in the activities that we will organize, as Ziv already indicated, conferences where we will attach a meeting specifically to our alumni and friends to it, to make this possible. I don't want to take much more of your time. We're hitting the hour as well. So I would like to finish with thanking all the attendees for being here, and thanking VLIRUOS to make this possible. And with that, I would like to close the meeting, and thanks again, everyone, and hope to be in touch soon.
Thank you very, very much. And also on behalf of VLIRUOS, we would like to thank you all for attending this community talk. We appreciate your attention and your participation. Sharing experience and insights is valuable, so we're grateful for your contribution. Of course, a special thanks to the speakers of today, Professor Annelies Agten, Dr. Issaac Singini, Dr. Levi Mugenyi, Professor Khangelani Zuma, Professor Ziv Shkedy, and Professor Niels Hens. We want to thank you for sharing your project research results and for having this insightful presentation and discussions. I personally learned a lot. I'm sure the audience did too. Don't hesitate to reach out directly to the University of Hasselt or to us, VLIRUOS, if you are located at one of the places that they mentioned where the conferences will take place. We'd happily provide you with more information. And allow me to take this opportunity to also look ahead and invite you for the next community talk. This will take place on April 30th from 11 to 12 before noon. That talk will be on another topic on waste and environmental pollution mitigation using innovative renewable technologies with a focus on the Mombasa region in Kenya. And this is a research between the Technical University of Mombasa and, by coincidence again, University of Hasselt, or as Professor Annelies Agten said in the beginning, it's maybe a small university, but a very impactful, so we can confirm that. So we warmly welcome you to join us next month. Stay tuned, follow our website, social media platforms for updates, and we wish you a wonderful day and hope to see you in April. Goodbye.
Bye.
Just to indicate that I've posted the link. People were requesting for the link to the website.
Yes, perfect, because some people indeed asked about it, so you can see it in the chat, and I will also maybe copy the link and make sure we can share it on our website.
Right. Bye-bye.